This video will demonstrate how to extract results data into an implicit field and apply it to various field-driven parameters. To begin, you will need to have a model with a completed analysis. Switch to the Structure tab and press the Show Analysis Results button in the ribbon. This will open the Analysis Explorer and allow you to view the results for the run. Pick the load case and result type you want to extract, and then press the Create Field button at the bottom of the panel. This will automatically create a new implicit part with an implicit result data object for each part included in the analysis with the result type that was active when the button was pressed. You will be put into the implicit field context with the last result data object as the driving function for the field. Reset the current driving function to select a different result data object. In this case, we want to use the data on the design space. We'll be applying this field to a lattice density, so we want the output units to be a percentage. Accept the field, and now we can apply a surface lattice to the design space part. Set the lattice parameters you want, and then enable the field for the density and pick the field we created previously. Press the Edit button to fine-tune the parameters of the field. We can edit the minimum and maximum values for the input range of the results data to better define how the results range maps onto the output range for the density of the lattice. Accept the field, and now you can see how the lattice density is mapped to the stress distribution from the analysis results. Here is another workflow for using results fields. We are going to apply an offset to some surfaces that were extracted from the design space. Let's create a new field for the offset amount and set the range we want for the minimum and maximum offset. We need to reset the default driving function and select the same results data on the design space from earlier. Let's intersect the offset volume with the original design space so we only keep geometry inside the design space, and then combine the offset volume with the lattice volume. We can activate a section view to see inside of the model to get a better view of the geometry. It is possible to edit the field and change the gradient by modifying the input and output ranges of the field. The exact same workflow can be done with results from fluids. Once a fluids analysis is complete, open the Analysis Explorer to view the results. Activate the results type you wish to extract and press the Create Field button. Just like before, you will enter the implicit field context with the fluid result object as the driving function. Again, we will use this field to drive the lattice density, so let's switch the unit type to percentage. Accept the field and then apply a surface lattice to the fluid volume. Set the lattice parameters you want and then assign the field that was just created to the lattice density. If the section view is enabled, you can clearly see the difference when the field is toggled on and off. By overlaying the fluid analysis results, it's clear to see how the lattice density maps onto the velocity of the fluid. A useful workflow is to create a pipe geometry where the thickness of the pipe is driven by the fluid pressure. Use the Extract tool to create a new part with the surfaces to thicken into a pipe. Use the implicit offset to start thickening the extracted surfaces. Apply a field to the outward distance, and we can try to use the previously converted velocity results, but it isn't the results type that we want to use. Accept the field and the offset and roll back the history to before we made the field, and then accept the edit of the implicit part. Reopen the Analysis Explorer and switch the result type to gauge pressure and press the Create Field button. Since we already have an implicit part, we get the option to either start a completely new implicit part or append this new field to the existing implicit part. In this case, we want to append it to the existing implicit part. The new field will be placed at where we left the timeline which we previously rolled back to before the offset operation. Since we are using this field to drive the offset length, set the units to length and put in the minimum and maximum offset amounts. Accept the field and roll the history back to the bottom, and we can delete the previous field that was made. Edit the offset operation and apply the new field to the outward distance. All we need to do now is intersect the offset volume with the original fluid volume. You can see the difference between a constant thickness and a field-driven thickness. And here you can see how that thickness maps onto the pressure data created from the fluid analysis. It's thinner in low pressure areas and thicker in the higher pressure areas.